The Fibonacci identity and Euclid's numbers. My motto? Plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. Euclid's identities for generating a Pythagorean triple a squared plus b squared equals c squared are a equals 2mn, b equals m squared minus n squared, and c equals m squared plus n squared. The identities are a direct consequence of Proposition 29, Lemma 1, Book 10 of Euclid's Elements. The self-same identities are produced by the Fibonacci identity when A is substituted for C and B is substituted for D. How the Fibonacci identity was derived in the first place, I simply do not know, although it is simple to prove. The slide shows two tables of numbers. The first table I class as applicable to the odd series rules, and the second table I class as applicable to the even series rules. The value in both tables are related by the formulas at the bottom of each table. In the odd series table, all even series have a constant b term highlighted red. In the even series table, all odd series have a constant b term highlighted red. Note that the constant difference in each table is the difference between a and b for the same series in the other table. The difference for the odd series are just the progression of the odd numbers. The differences for the even series are just the progressions of the integers. All series contain non-primitive triples at regularly occurring positions which are governed by the prime divisors of the difference between the base numbers CB of the triples. The exceptions are the first odd series and the even series where the delta CB is equal to 2 raised to an odd power. Euclid's numbers demonstrate that an infinite number of infinite series of primitive Pythagorean triples exists, an infinity of infinities. Finally, there are more even than there are odd series as we total the number of series. For the first 10 series, it is 6:4, a ratio of 1.5. As the count increases, the ratio converges to root 2, so that although root 2 is irrational, we can nonetheless get better and better approximations to it as a rational fraction. What would the ancient Greeks have made of that if they had known?